Hi there, welcome to today's video. In this video, we are going to unfold the transformer architecture. Transformer is one of the deep learning models that was introduced in the paper Attention is All You Need by authors Vaswani et al. In the last few videos, I have been introducing the concepts such as multi-head attention, scaled dot product attention. Now that we understand those concepts, understanding the transformer model should be relatively straightforward. So let's get started. To begin with, think of transformer as a black box. So it's a deep learning model, which is represented by this big box, and it takes in some input, and we expect it to give us some output. As an example, let's say we want to do translation from English to French. So we will give it an English sentence, and then we expect the transformer model to give us a translation in French. Now, what is inside this box? So inside this box is an encoder and decoder. The transformer is a deep learning model that is based on an encoder and decoder architecture. So what we mean by that is the transformer model, it takes in the input, and usually that input is not the raw input. For example, let's say we have text. We know that neural networks, they do not understand letters. So we have to convert that text and vectorize it. That's called input embedding. So we take our input, do the pre-processing to get the input embedding, and we pass that to encoder. Usually we have more than one encoder. That's what is represented by this N. So this encoder takes in the input and it encodes it. Then that encoded input is passed on to the decoder. Inside the decoder, we convert it to whatever translation we have to do. I'm just giving translation as an example, but there are many more applications of transformers. So then the decoder decodes it, and we get the output as a translated sentence in French from English. Just as an example. So what we need to get away from this slide is transformer is a deep learning model that is based on an encoder and decoder architecture. Before we move deeper into understanding what is inside this encoder and decoder, another important piece is positional encoding. You might remember from one of the previous videos when we studied about the scaled dot product attention and multi-head attention. We saw that when we do the attention, we pay equal attention to we look at all of the input at once. So if you have an input sentence, we look at all of the sentence at once when we do the multi-head attention. What is lost when we do that is the relative or absolute position of the words in the sentence. Sometimes the actual position of the words in the sentence is important, so we want to preserve that because that is lost when we do the attention. So what we do is we take the input and we add the positional encoding for all of the input tokens. So what goes into the encoder is the input embedding plus the positional encoding. All right, so this is the input, total input that goes into the model. Now let's get deeper into what is inside the encoder and decoder. Inside the encoder, we will take a look at the encoder first, and then we'll move on to the decoder. So inside the encoder are two main blocks. One block does the multi-head attention, and then the second block is a feed forward block. Feed forward is basically it contains a bunch of dense layers, which are fully connected layers. So what happens is the input, which as we saw in the previous videos, we represent that input as key value, and query. So these three, which refers to the same input when we do the self-attention. So these input goes into the multi-head attention first, and then once whatever comes out of the multi-head attention, we add to it the original input, and then we do the normalization. So what comes out of this block is then passed to the next block, which is the feed forward. Again, this is just a bunch of dense layers, fully connected dense layers. So again, we take the input, we take the output of this block and we add that to the output of the feed forward network, and then do the normalization, and finally we give out the output from the encoder block. As we said before, usually there is more than one encoder block. So essentially the output of this encoder block will go to the next encoder block, and depending on how many encoder blocks we have, then from the last encoder block we send the output to the decoder. So now what's happening in the decoder? It has the same blocks as here. The main difference here is where does it get its input from. So in this case, so let's say we are doing as language translation. So when we are doing the language translation, let's say we already have the first translated word. So let's say English word was I love you, and then we want to translate into French. So let's say we have the first translation of I. Now what goes into the decoder is all the previous outputs plus the encoded part from the input, which is the English language, because we want to translate the complete sentence. So here the query comes from the decoder, but the answer, which is key value pair, it comes from the encoder. After that, it just with this small difference, rest of the stuff is the same as the encoder. So we have multi-head attention, and then we have the feed forward network. So that's the transformer architecture in a nutshell. So in summary, transformer is a deep learning model which is based on encoder and decoder architecture, and some of the important concepts before we understand what transformer is are scaled dot product attention, multi-head attention, what is feed forward, and some other terms. All of these have been introduced in my previous videos, so that's why I'm not repeating. But these are some the terms that we would need to know to understand the transformer architecture. Now, if you really want to understand what I would suggest is to go through the original code from scratch. So we can look at the code here, and I will jump into it. So this is the example which is available in the TensorFlow and is written by the TensorFlow authors. And this is an example of language translation from, I believe it's from English to Portuguese. So what I would suggest is go through this example line by line, because it really dives deeper into everything that the paper has. You can see how they are setting the input pipeline, but more importantly, you will get to see how the scale dot product attention is done, multi-head attention, encoders, decoders. So it's really a very helpful notebook that I found. And one thing I want to point out is, as you study about each of the blocks, it also has examples. So for example, let's say you want to test your multi-head attention. Here, you can just give it input as an example, and then you can understand what type of output you get. So beauty of using the Colab or Jupyter notebook is that you actually can print out the results and see the results after every step. So this is what I would suggest. If you want to really understand the transformer model, maybe you have read tons of papers and tutorials, but this is how you will really understand by diving deeper into it. So that's it for today's video. And if you love the content on this channel, please feel free to subscribe. And with that, I will end the video for today. Thank you.